have to see a counselor, or you gotta come in for some reason, but no classes. And then Thursday and Friday is completely closed. So we'll be meeting the following week on Thursday. It's, I call it a review session, I think that's what we call it. Oh no, we're gonna make one more adjustment. I will do a review, that's December 5th. But I'll do a review and, we'll do one more little adjustment to the floor pan. And I'll probably make the final available that day also. It's technically gonna be on the 12th, the final. And I always write the final exams, you know, so you could do them in an hour or two, because it's always been, you know, the last day you had a final. But I'm gonna make it available the week before, so you'll have a week to work on it, even though it's still just an hour or two worth of work. So anyway, that's how we're gonna do it. So this assignment for today, it says holes set up for cross members. We're actually setting up some holes and making the holes. It's essentially creating 8 holes on the 2 cross members. But I'm gonna spend most of the time talking about this one. The same, you're gonna repeat the process almost identically on the back one, but you'll see when you get, I don't know if you got to this point yet, on the last page, after you do the front cross member, there's 4 holes on that one. I'll walk through that. Then the next page, this is the last step, it says, repeat all that, except do it on the rear cross member, so you have these 4 holes. So the process, it has you create some points in specific locations. Well, for the rear, there's gonna be different locations, so I give you that information here, but I'll talk about it when we get to it. I'm not gonna demonstrate all 4 holes, I'm just gonna demonstrate the ones up here. You're gonna do the same thing, but just with some different point locations, right? The biggest thing about this is not really creating holes. Creating holes isn't necessarily complicated. I mean, it can be, but what we're gonna do in the exercise, we're just gonna create some holes and point them at the right places on the cross members, and then subtract it. Right. More important is just how we're gonna organize it in the navigator. Okay. So the first thing, and I've already done a couple of steps. First thing is in the cross member right front seat front, I'm gonna make that the work part. And I already put this feature group in here called holes. A neat little trick. To put it in here right when you create it, it basically said, first make the U channel feature group current. So that means it's bold, like so, right? That means its parent was active. But if you have it like this and then you insert a feature group, right? What the current feature means, whatever you're creating next, including a feature group, will go right after that. So that's a shortcut way of creating a feature group and putting it right here, because we wanted it right after the U channel, not inside the U channel. If we would have just said put it inside a form, well, it would put it inside a form, but at the bottom. And you could move it, but if you say, well, let's make this current, then it'll do 2 things at once. It'll put it inside the form right after the U channel. So anyway, I already did that. So I got a holes feature group, then I'm gonna make that active, because the next things I'm gonna create go in the holes feature group. Okay. Then it says, find those 2 points we used a long time ago. This is the front right cross member. Find those 2 points. They are in the top of the tree because, well, if you made them the way the instructions told you, they're not in the navigator in the model history. They're non-parametric because I told you to make them non-associative. If you did, it's not the end of the world, you can still use them. But the reason I wanted to make them non-associative is because I lined them up with those seat tracks and risers, those other parts, but I didn't want the points to be associated to them, I just wanted to line them up. So I made them non-associative. If you did that, they're in a folder up at the top called non-timestamp geometry, which is anything that you make non-associative. Mine shows 3 points in there. There was also one in the middle. And yes, you can unpack that. If it says point times 3, you can unpack it and then you can just find which ones you want. So it's those 2 points, I just made them visible, okay? And like I said, it's kind of basic stuff. We're gonna make holes. Now, when we do the holes, you know, the whole command, if I just go to it, you can subtract things on the fly. But what we're trying to show in this exercise is, yeah, we could make the holes right now and subtract them as we create them. But a lot of times, you're organizing the tree a certain way where I'm not gonna trim anything yet. I might design the trim pieces and the holes and the slots and cutouts and all that stuff. I might design all those, but not necessarily subtract right away. You know, first I'll get all the geometry done, the form of the geometry, and then, as one of the last steps, I will take all the trim pieces we made and subtract them all at once. So when we make the holes, it says set the Boolean to none, okay? Now actually, I'm gonna reset that, the whole command. So if you do a simple hole, by default, yeah, you're picking a point. And custom just means you're typing in a diameter, right? And we're gonna use 13, I can type in it right now, because I wanna make a hole right here that's perpendicular to that face, although I'm doing it a different way. By default, the type for the direction is normal to face, okay? What that usually means is when you pick the first point, say I picked that point, if that point was related to that face, it might have picked it up, but you notice it didn't. It says normal to face, but I don't know what the direction of the hole is gonna be, okay? The real reason is, excuse me, that point, technically it's not really on that face. If I can zoom in just right. See how that point's not on there? Okay, if the point was directly on the face, it would behave a little bit different. I'm just saying this to remind you a little bit about the hole command, right? So, and I am telling it, don't do a Boolean. So I don't know why it's asking me to select the body. I don't need to because I'm not subtracting it from anything. But for the hole direction, it says normal to face. It doesn't know what face to be normal to. Usually, if you have it on normal to face, this is where I'm going with this. If you're creating a hole and you have it on normal to face, you do want to subtract it, and the point should be right on the face. So it knows normal to what face, it would know it, right? So now let's see, if it's really asking me for a body, but if I pick the body, and it doesn't say select face, I can't say just do single faces, it's gonna take the whole body. And if I pick that, I think it's gonna give me an error, or an alert. It says, well, it doesn't know what's the target body for your direction, right? One reason is because the point's really not on the face, so it doesn't really know which face to pick. It just says, well, this body, what's normal to it? Well, there's a whole bunch of different directions that are normal to it. So again, it's failing if I do that normal to face, because the point wasn't on there. And just to show you something, again, this isn't part of the instructions, but if I go to project, I want to project that point, even though it's a point, I think we did this last week. If you want to project a point, remember there's no command called project point. You have to go to project curve, and if you read this, you'll see that inside a project curve, you can also project points. It says curves or points to project. So what I'm trying to do is put that point right on that surface in a normal direction, so it's actually projected from here to there. That's right on the surface. Just again, just to show you something about the hole command. Now if I go back to the hole command, I'm doing this in the holes feature group, by the way. And I got everything set the same way, but if I pick that point, see how that automatically knows a direction, what to be normal to. I can still turn off subtract, but it knows that that point was related to that body at a specific face, or right on a specific face. So if I have it on normal to face, that's what it's using. However, best practice wise, it's not always a good idea to use faces if you don't have to, because faces might change. And that face is flat, so yeah, that works out fine. The system could pick out a normal of that face, but it's not the best way to do it. So what I'm going to do is cancel, and I'll undo that last point I made, or I'll just delete it. And it's called a projected curve, even though it's a point, because I projected a point. I'll just delete it. The way I have you do it, and it's actually a pretty commonly used way, is for the direction of the hole, I'm gonna create my own direction. I'm gonna create a line. So I tell you to go to the line command and create a line. It doesn't really matter how long it is. It's just mostly based on how does it visualize, right, when I make the line. So you're gonna make a line perpendicular. I'm gonna say start at this point, but the end is gonna be normal or perpendicular to a face, but you gotta be careful, because it says select something to be normal to. I wanna pick that face, but this is set to tangent faces, which means if I pick that face, it's gonna pick everything. It does say in the instructions, use single face when you pick the surface, so set it to single face. Normal to what? Normal to that. And again, the length isn't important. I don't know why it's 1800 millimeters, but I tell you to go like 15 in one direction and then minus 15 in the other direction. I don't know if it's that way or that way, but that's big enough where I can see it. You can kind of tell where it is, right? Could be a little bit longer, could be a little bit shorter. This one, I am gonna leave it unassociative. It doesn't really say if you have to or not. And yeah, I guess I'll do what I'm gonna make you do. I'm gonna rename it. It says, call it C line attachment hole 1. So we're gonna make different holes in different places. So, and it's kind of important to name it that, because that's what we're calling an attachment hole, right? There's an attachment hole. We're gonna make another hole that's called a principal locating point, or I should say point. That's a PLP, so anyway, that's attachment hole 1, all right. Then, and again, I could make, I'm gonna need other lines, because I'm gonna make other holes in different spots. And I could make all the lines first and then the holes, but in the instructions, it has you make one line and then make a hole right on that. It says go to the hole command. Okay. But right off the bat, change it, instead of normal to face, we're gonna pick a vector, and that's why I made that line. Okay. So when I go to specify point, I am picking that point. Okay. But for the, oh, that was in the wrong field, never mind. Unselect that, go to specify, pick point, pick that point, then go to specify direction. Because I said a long vector, I have to pick something that defines the vector line, and we're basically gonna pick that line, okay? There's a little arrow there. Most of the hole, I mean, the top of the hole, it's gonna be like a cylinder. Think of it as a solid cylinder, the hole itself. And I am gonna turn off subtract, by the way. So that's what it looks like. It didn't show it when I was doing the subtract, but it's gonna look like that. But if I leave it like that, it's not even touching the metal. It's gotta go the other way. So you can double click the arrow, you can hit reverse there. That's going through. This is gonna be a 13 millimeter diameter. The hold command, by the way, is always diameter. I don't get to choose radius versus diameter. So if you're given a radius for the size, you gotta double it. Let me type it in there. Okay, and let's see, the length, it only needs to be 15. And that's all I'm gonna tell you to do, I think. Yeah. But it says turn off the Boolean, okay? So it's going back to what I said. You can create a hole that isn't really a hole yet. It looks like a solid, right? The idea is it's gonna be subtracted, so, but that's what it is, okay? And that's supposed to be trim attachment, trim surface. I'm using names that the guy who made this class a long time ago, the guy who worked on floor pans, this is what they called these holes. So the first thing was a line that I called center line for attachment hole 1. This is the trim surface attachment hole 1. Okay. It happens to be number 58 in my instructions and number 58 there, so I must have done it pretty close to my instructions. Then it says repeat the process over here. So I'm still in the hole command. I'm still in the holes feature group. So I'll do a little faster. A curve, I'll go to line. At that point, the other end's gonna be normal. Normal to that face, make sure it's on single face. I'll go 15, and it's already at minus 15 on the other side. Then we go to the hole command. So like I said, you know, this is not high tech. The hole command is the hole command, right? But for the direction, I'm gonna pick that line, reverse it. The numbers should all be good. Make sure it's not being subtracted. Okay. And I won't bother naming them. That's the attachment hole 2. I'll do it later, but you don't need to want to do it. Then we're gonna make some points, or we need a couple of holes that are gonna be in the top of this. We're a hole over here and a slot over there, okay? So the hole is gonna be pretty simple because holes are circular. But the slot, we're gonna have to actually draw the shape as a sketch. So how do we get the point right here? Well, I'm gonna make a point at a certain X, Y, Z in space, and then project it straight up so it shows up right where we need it to be on the top of that cross member, right? So it says go to point command, so it's behind line, or I'm sorry. It's right there in the curve group, curve tab. And we're gonna do an inferred type. I'm gonna make sure I do it the way I'm telling you to do it. And then we're gonna key in the values. So it's 2030 in the X direction, because remember that the absolute thesis is way over here, the main thesis. So we're gonna come out 2030 there. And if you look at it, it's kind of centered in the middle of the cross member, but we need it to come out this way. So in the Y direction, it's 610. So it's now directly under where we need. And I could put it anywhere. I'm not gonna try to put it right on the surface. I mean, we could try to figure out where that would be, but you know, if the surface changes, then the coordinates of that point aren't gonna change necessarily. So we can just leave it at the Z. I'm making it associative, I'll hit OK. Then we're gonna take that point and project it up. And remember, there's no project point. You go to curve tab, there's project curve. You can pick a point, and then pick that point. The object to project to, and this one we're not gonna do a long face normal, we're gonna do a long vector. Because if we do a long face normal, we pick this top face. I'm gonna select object, and I'm gonna set single face. I don't think it matters, but I'm gonna pick single face. Even if I pick body faces, if I tell it to go in the Z direction, it's still only gonna know enough to hit that face. But for the vector, I'm actually gonna pick the Z direction. And you can see it's projecting it there. That too is not anything high tech, but it's kind of where we're doing it in the tree. Right? So let's see. Did I tell you to name that? No, I don't name that. So now we're going to make a line. This time we're going to make a line normal to that face. So that tells us where the middle of the hole is going to be. But the direction of the hole, we want to make sure the direction of the hole is normal to this. So if you take a cylinder and you slice through that tilted surface, it's a true circle, right? If I had the hole going straight up and down, it might look like an exact circle, but if it goes straight up and down and goes through the surface that's a little bit of an angle, it would not be a true circle. So our design intent is the hole is a true circle on that face right there. So we're gonna make a line. And I'm still in the holes feature group, same way I did before. Normal to that face, same values. Okay, and another hole. I think even the hole, yeah, with the same values. Do I really need to show you that? I'll do it. It's not that long. Now that point, I probably could have used the other method because that point is truly on the surface. These holes, or these points, were slightly in front of the surface. But a long vector is a good way to do it because that way you are controlling it with something that's a little bit more stable. A face can change quite easily, whereas this line, that line is going to be wherever I put it. Now there is a subtle difference. Here you can see, because that point wasn't on the surface, the edge of the hole is a little bit sticking outside of that. This one, the point was right on the surface. But as long as it's touching, it should subtract itself, right? Now the last hole I'm going to make, it's a slot. Well, I guess I got to make a point. It's going to be over here. So we are going to create a point. Go to curve tab, go to point. This one's going to be at 2030 in the X, but not 610. It's only on 110 in the Y, 0 in the Z. Make sure I'm saying what I'm saying. Yep, and then we hit OK. Then we project that point up, just like we did last time. That point up to that part in the Z direction. That face, I should say. Okay, but now is where we're going to do one thing a little bit different. Not really much different. Oh, it does say create a line. We are going to create a line. technically we could do it without really creating a line. I mean, we could create a line on the fly, but I basically say the same thing. Make a line there, normal to that face. Okay. Now we're going to create, because I want to sketch, and I want the sketch centered right there, I'm going to create a CSIS right there. It's always a good habit to use a CSIS if you want to make a feature, especially when it needs a sketch. That way, if it's possible, you make the entire feature all tied to that CSIS. So if I go to Datum CSIS, and there's different ways to make a CSIS. Because I have a line, I have a couple of lines I can use, and I have a point. There's one called Z-axis, X-axis, origin, right there, which is pretty intuitive if you read it. First it wants an origin point, I guess it wants that point. Okay. Now, remember this too, if you pick it too quickly, you might be picking, instead of the actual point you made, you might be picking the midpoint of that line, which could change if you made one of the ends of the line longer, but make sure you pick the point. The Z-axis, we want it tied to that line. And then the X-axis, we want it tied to the actual CSIS, the real CSIS that's out here. But on my, I guess I should have said this. I want my sketch to look like this when I'm looking at it from above. So, you know, horizontal is X, vertical is Y. So I want the sketch CSIS, I want that way to be X. Okay. I guess it doesn't have to be, but that's what I wanted. So the X of my CSIS should be tied to the Y of this CSIS. Previewing it, looks like what I want. Looks like my picture in the document. So I'm going to say, okay. Then we're going to create a sketch on that. It says create a sketch on the XY plane of the slot datum, right? Another quick reminder. I could just go to Sketcher, and I could pick the XY plane, and that would work. That would be exactly what I wanted you to do. I just want to remind you of something. If you have a CSIS floating out there somewhere, if you already have the XY plane in the correct spot, remember, you can actually just click on a CSIS. I didn't pick the plane, I picked the whole CSIS, and it offers a sketch. Okay? And you click on that, and you think, well, how does it know which plane to put it on? It always goes to the XY plane. Okay? If you simply click on a CSIS and say create a sketch on there, it goes to the XY plane by default. So if you're going to do that, make sure your XY plane of your CSIS is where you want it to be. All right? Then it says, all right, let's create a slot like this. Now I do, if you read this, I might have confused you a little bit. It says the arc centers are constrained to the horizontal or the horizontal axis, and then it says and symmetrical about the origin. Okay. Well, I actually don't have symmetry, a symmetry constraint in this sketch. The way I made it symmetrical was this point is 4 mils from the vertical center line, and then the other point is 8 mils from that one. So if that's 4 and overall it's 8, then those are symmetrical about the center. You could have actually said, well, make this one 4 and then make these two symmetrical using the symmetry constraint. You can do it either way. I don't care what way you do it. But anyway, and another thing too is NX. One thing I wish it had, kind of like because CATIA has it in Sketcher, you can easily make a slot in CATIA just by saying go to the slot command and you just kind of pick the center. In NX you kind of have to draw it. So I'm using the profile tool, and I'm just going to say, well, I'll start like this, and it'll be something like that. I don't really care about the exact numbers just yet. There's my slot. Okay. And it just the way I did it, you can see there's tangency constraints. It actually made 2 lines and 2 arcs, and they are tangent. If you're drawing it and you didn't do it exactly like I did, if you move your cursor slightly, it might not be tangent at some of those locations. So remember, if you don't see the little slot there for tangency, pick the arc and the line, and then you pick the tangency constraint because the mine's already tangent and have it available. So let's see, quickly I'll do a linear dimension between this, and I say pick the sketch vertical axis. That's that green. It says Y, but it's the vertical axis, and that should be 4. Okay. And then from that one to that one should be 8. And that would make them symmetrical, right? That's 4 and that's 8, and then that must be 4 on that side, right? And let's see, the points are both sitting right on the horizontal axis, so you can pick a point, horizontal axis, point on curve. And you notice the bottom was not locked at horizontal, so that one didn't line up automatically, but if you pick a point on the horizontal again, point on curve, technically that doesn't need to be horizontal now. And then I think the only thing I still need is the radius, only one side or the other. The picture says a radius of 6. Remember, because somebody had this question before, if you go to radial dimension, check what yours is set to. Mine's set to radial, but maybe you made one earlier that was a diametral. So if it's set to diameter, you can use diameter, but if it's a diameter, it'll be 12. But if you're using a radius, it'll be 6. So pick that, place it, and make it 6. And see how it's all green? Sketch is fully constrained, that's everything I needed. All right, finish the sketch. And now, I can't make a hole with that. So we're just gonna use what I know you're thinking in your head, well, I know what you can do. We can do an extrude of that part. It says 15 in both directions, so we're kinda, which is like minus 15 and 15. We're kinda, using the same size we did before, 15 in both directions. And of course you're gonna name it. And again, we don't want to do a Boolean right here, because that concept we're saying, no, let's make all our negative material but not use it yet, okay? Now that I've done that, and here's where I could do this a couple different ways, but what I have you do is say, let's make the last feature current, okay? Which is that point at which I had our final form before the trim, which was, let me jump back here real quick, it was this thing, right? We had that, and then we trimmed it with that one little U-shaped thing to make this. Okay. Well, I don't want my history to be the holes are subtracted as the very last step. And again, this is debatable it's all about where do you want to subtract the holes from the part, right? So what we were saying is I wanted the last feature in my part to be when I trimmed the form with that U-shaped thing. So that means I want the holes to actually be in there before I did that. Well, we can do it a few different ways. We can go back in time. The way I have you do it is make the final part's active, and then it says create a new trim sheet, right? So I already have a trim sheet, that's my final part so far, but it says create a new one. And then it says, from here, pick the boundary objects, right? And again, now they're different holes, right? Or there's 3 holes and an extrude. Set it to body faces, and then one at a time, you can pick any of these. Doesn't really matter what order you pick them. So I picked that, and right away you get an alert. It's kind of scary. One or more boundary objects do not trim the selected target sheet body. That's only because body faces pick every face on this. And so there's a cylindrical face, there's a conic face, and there's actually kind of a disc face right there. Well, that disc face, remember, it's outside of the part. Can't really see it there, but if I move it like that, you can see it. So it's saying, well, you're trying to trim with this face, and that face isn't touching that. That's all it's saying. It's okay. The cone inside is not touching it either. It's okay, it'll still work. So that alert doesn't stop you from continuing. I picked that. Oops, I picked the curve that time. I messed it up. Let me deselect that. With body faces, I'm going to make sure you pick faces. Okay. I'm still going to get those messages. Pick that one. And since I'm looking at it underneath, oh, yeah, there it is up on top. Pick that one. Even though I got that alert, I can still hit OK. And it did remove all those. And you're thinking, no, it didn't. I don't see that. Well, just like when you do a trim sheet with 2 sheet bodies, it didn't hide all the holes. So I might be able to come up here and just turn off holes, and you see it really did subtract it, right? Now here's the thing, that made a new trim sheet feature. It's at the end of my history. So now my history shows that, well, you did that trim where you took all your form and you used that U-shaped trimming piece and you chopped off most of the form. But that's no longer the end of my history. Now that it says you did the holes. So what I have you do is, it says drag that trim sheet. I mean, if you look at the names on the bottom of my tree here, it says cross member, right front seat, front defined. Well, that should have been my finished part, but it isn't. If I go back in time to that one, the holes aren't there yet. Now technically what I would, I could have just said, just take the name off of that one and put it on that one, right? But it says, take the trim sheet and drag it right before that one. So that's what I'm talking about. I just want to explain this a little bit. When I do that, that trim sheet right there was taking the holes out. This trim sheet was taking the big chunk with the U shape out. Okay. So now if I go back in time and look at, well, that trim sheet, which is just the holes coming off, if I go back in time to that, see, it looks like the entire form with the holes being taken out before I chopped away all the excess. So we're kind of saying with the instructions, that's what I want it to look like. I want it to say, I want my history to say, first you took all the holes, then you trim the rest of the geometry. All that excess weld flange stuff, right? But that's how the instructions end. But I thought about it a little bit, and I thought, that's not necessarily organized the way I'd like to be. If I could say that as soon as I made the holes, right? Right here it says final form before trim. Well, maybe, and it's all semantics maybe, or whatever. The final form before trim, maybe, before what trim? And I could say before that last trim with the U shape. So what I could do technically is take this trim sheet and drag it. Let's see if it lets me do it. Right there. So that's now the new final form before trim. It is coming right from that. If I put it right there, now sometimes it moves the trim set. I don't know why it does that, but it moves the trim set. I'll just move it back. Trim set should be right there. Yeah. Okay. So again, I don't have you do this, but I'm just trying to be logical about it. Let you think about it a little bit. Now I have something called the form, and the last thing in the form is that trim sheet I just made, which looks like that, which does have the holes in it, but it doesn't have the rest of it chopped away. So you could do it that way. And to me, that I'm thinking, well, that also seems logical, but both ways seem logical. But I'm going to show you one other thing, and I'm thinking of even redoing the instructions for this. If I go back, before I did that last trim sheet and I moved it, okay. Here's another thing I might do. It's kind of what I was talking about at the beginning. In fact, I'm even going to delete that trim sheet. I'm just undoing until it went away. So I had the holes. I got all the holes here. Okay. And I didn't do another trim sheet, but this is something that might be a better way to do it. Like I said, I want to organize my parts. So everything I did so far was the form, where there's no holes, no trim, no cutouts. And real quick, I'll look at it. It was this. Right? No holes in it. Come on. But I want to leave that as the form. Well, then I have a couple things I'm trimming with, right? I'm trimming with that U shape, but I'm also trimming with some holes. What I could do, and I might change the exercise to do this, if you want to watch this real quick. If I go to the trim sheet I already have, right now it looks like that. This is what we did a while back. we had that big trough, and then I trimmed it with that U shape. Well, when you do a trim sheet, you can pick more than one boundary. I've got the holes, why not say, you know, yeah, my one boundary is that U shape, but while I'm in here, I can also pick with body faces, that one, that one, that one, and that one. So you see what I'm doing? I'm actually changing my trim sheet, which is the final operation. I'm changing it to say, not only am I just trimming the outside of this weld flanges, I'm also trimming all the holes. So you can do it all in one step. So that's slightly different than what I had to do in the instructions. So anyway, I don't know if you're paying attention to all that, but that's something that's discussed, and it's something you'd think about when you're organizing the part, right? How the history of the part is. In my case, the way I just did it, I have different features that we're gonna trim stuff away, whether it's flanges, cutouts, holes, slots, whatever. And I just used all of them at one time. I did one trim sheet, took the form, and picked all those things in one operation. The way I have you do in the instructions, you do two operations. You trim with the holes, then you trim with the other thing. You can actually do it either way. I won't mark it down if you do it the way I just showed you. And then, like I said, I'm not gonna demo this, but now it says, do that on the cross-member right front seat rear, okay? Meaning, you're gonna create points, you create lines, and a couple of them are gonna be right on the flush with the main top slab, and a couple of them are gonna be on those two pads. For the holes that you're creating, it says, well, on the top of the pads, there should be a couple of points that are hidden, you gotta show them. Right, so for these two holes, you have points already. But for these two, you're gonna did like I did. I created some points using coordinates, like right here. X 2455, Y 470, Z 0, and then you can do another one. X 2455, Y 340, Z 0. So you're really just doing all the same steps. You're gonna make a sketch, the exact same sketch you did over on the when I made the slot, but it's just over here. But you don't need to watch me demonstrate that. Okay, does it make sense? Yep. You see what I'm saying by, you know, we could organize it a few different ways. When do you trim them, right? So there is no one answer to that. I'm just showing you that there's different philosophies when you trim stuff. You can make a hole and trim it, make a hole and trim it, make a hole and trim it. Or, like I said, a lot of times I made all the holes. They were in this thing called holes, but I didn't use them to trim it until I did the very final trim sheet. So now you have that knowledge in your tool. Yes. Question? All right. Remember, no school next week. School's out.